little bit about the entropy as a measure. Okay, so for attribute choice for splitting the data set, and you see there in this example risk of heart failure, we have given some example data: age, BMI, alcoholic are the features. So these are the numerical features you can see, and that is the kind of categorical alcoholic yes or no kind of feature. So here, one thing I want to tell that let's consider age will be the root node or the first the decision matrix based on which we will divide the data. So and then assume that based on age, when we divide, then in this side, left side and right side, we divide the samples which are like high, low. Let's say plus and minus. High is plus and low is minus, and we divide the samples. Okay. So now we have to check. So let's say that's a feature 1, and feature 1 has 6 positive and 5 negative when you split them. Okay, on left side you have so total it has like 6 positive and 5 negative, 6 high and 5 low. And then so let's say it looks like this. Okay, 6 positive samples and 5 negative samples. It's considered very impure because it's a very kind of equal mix of positive and negative samples. Now let's consider something partially impure where there are more positive samples than the negative samples, and positive samples are like twice, or I mean it's pretty big, the difference. So it's a partially impure, and something is very pure when there are like positive samples in one group and negative samples in another group, and they have no mix up. Okay, so it's a pure splits, and you can see this that our objective always to go to from impure splits or random it's a random combination of elements to more pure split where there will be one particular category and another group will be another particular category without any mix. So that's the objective. Now so if we feature 1 has 6 positive and 5 negative this case, and if we divide them in two parts, left and right, and where in the left part has like 3 positive, 4 negative, and in the right node has 3 positive and 2 negative, then we have to calculate the entropy using the Claude Shannon's famous entropy formula, where E equal to minus of sum of the probability of different samples and the log of the probability. So multiplication of probability and the log of its probability for all the samples. I call 1 to n, and put a negative sign before that. Okay, the why we put a negative sign before that I'll explain to you. Now before that, let's see that how it looks. So for a particular subset of the training example, if we calculate the entropy, it will be minus p positive times log p positive minus p negative times log p negative, where p positive are the probability of the positive class and p negative is the probability of the negative class. Okay, so here you can see, because we are taking the log of the individual probabilities, the probability here it's a fraction. Okay, probability is a fraction. So because of that, for a proper fraction, the when you take logarithm, it will be log of the numerator minus log of the denominator, because denominator is bigger, so this log p term will always be negative. To buffer that or to counter that, we put a negative sign before that so that the entire thing becomes positive. Okay, that's why in entropy formula there's a negative sign. So now you see an example. We calculate the using this formula, we calculate the entropy of this left node and the right node, and then make a weighted combination of them. Okay, so what is the this is the formula for the left node: minus 3 by 7, because there are 3 positive samples, 4 negative samples. So it's 3 over 7, it's 4 over 7 for the negative sample part if you follow from this formula, and then the logarithm of the corresponding fractions. The calculation, so all these logarithms are using base 2. Okay, you can use natural logarithmic base also. We have done it using the base 2, and the result becomes 0.9842. I have not shown the step-by-step calculation. You can do it for yourself. And let's call it the entropy for the left node. And similarly, we calculate the entropy for the right node, where we have 3 positive. So it's 3 divided by 5 and 2 divided by 5 for 2 samples. Negative samples. Okay, and the calculation, so you can see that they are very close, like 3 4 3 2. So they are very close to 0.99. So this is 0.97. So they're very close. If we can make it a little bit like 5 and then 2, then the entropy will reduce more, because there will be less randomness. But I deliberately choose this to show you the difference. Now you see the average, the weighted average we calculate for these two cases, where we are trying to show that, okay, we divide them in the left and right nodes from this root node, and what are the total probability or weighted average of the probability of the created, or sorry, the entropy created by these two nodes. Now the weighted average is 7 over 11 times EL, because there are 7 samples among all the 11 samples here. So 7 over 11 times EL, the left entropy for the left node, and 4 over 11 times entropy of the right node. Okay, so this becomes 0.979364 is a 6-digit post decimal. And now I also calculated the for this parent node the entropy, which is 6 positive samples divided by 11 samples times log 6 over 11 minus 5 negative samples over 11, and then the result comes 0.994028. Now I want to check, after splitting this node based on, let's say, age, I get this two left and right nodes. Did I reduce my entropy? That means if I reduce my entropy, means I will have information gain. So information gain has to be positive in that case. So information gain is for the parent node, whatever be the entropy, and then the weighted average of these two child nodes. Okay, EP minus EAV, we already calculated this. It's called, let's call it a EAV. EP minus EAV is 0.014664. It's little less. Okay, if I choose the samples in a more careful way, I will have better, more higher positive number. But it's still positive number, and it shows that if we divide it based on age, I gain. I have information gain. So I can use age as a. So in that way, using BMI, using alcoholic, all of them, I have to do the same procedure and then check which one gives us the maximum information gain, dividing by age or dividing by BMI or dividing by alcoholic or not. And then whichever gives the maximum information gain, we'll choose that node as the root node, and in that way in every level for that as a decision node.